Welcome to Math 31, where we are looking at limits, and this is an Introduction to Calculus course. We are in section 1.4. So over the last couple lessons, we've been just looking at how do we calculate limits of functions, either graphically or from the equation. We got into left and right-hand limits. We talked about continuity and discontinuity. Well, now we're going back to the whole motivation where we started from looking into limits. And that was the idea that to find the slope of a tangent line, we need to find the limiting value of the slope of a secant line. Before we get into that though, just a couple review questions here, much easier than things you've been doing over the last couple lessons. So pause the video at this point, do these two warm-up questions, and then restart the video, please. You can pause now. Question number one. For our radical function, we are just replacing the x with a -3 and evaluating. Again, sometimes we have a question that comes up with questions like this, where we're wondering, well, how come this is just a +2? Why is it not a -2? And the reason is, in our original function, we had the square root sign. In front of it, there was an invisible plus sign. So we were looking for the positive or principal square root for this function. Question number two will be similar, but this time we're replacing the x's with this other function, -3 plus h. And then we simplify as much as we can, and that's all we can do. Well, the usefulness of this will come up later in the lesson. But let's come to this idea of the slope of a tangent line. So here we want to find the slope of a tangent line at the point P. So here's our fixed point P on this curve. So this is the function y equals f of x. And so as you notice this graph here where x is 1, the y value is f of x1. And here where we have x2, the y value is f of x2. And again, as we looked at the secant line that we can see here, what we're doing is we're taking this point Q and we're going to move that point closer and closer to the point P and then see what happens to the slope of that secant line. So given the notation we have here, our equation for the slope of the secant line looks like this: f of x2 minus f of x1 over x2 minus x1. If we want the slope of the tangent line, then we find the limiting value. So we'll do the limit as x2 approaches x1 of f of x2 minus f of x1 over x2 minus x1. Well, the next two diagrams are going to be looking at the same situation. We're just going to use different notation. So as you look this time at our notation, some things have changed. Now we have an a value here. So a represents a number, which makes sense. This is f of a, so the ordered pair for this point is a comma f of a. It's some fixed value. But we're using an x over here because our point is moving, it's variable. And so our y-coordinate is the f of x from over here. Using this notation, the slope of the secant line will look like f of x minus f of a all over x minus a. The slope for the tangent line will be the limiting value as x approaches a of the slope of the secant line. We're going to call this formula 1. So this is one of the formulas that we'll use as we calculate slopes of tangent lines as we work through this unit. One more notation. This time what we've done is we still have this point A here, but now we've replaced the x with an a plus h. So here, this distance in between these 2 points is h. And so as q will be coming along our curve and it'll be approaching p, this h value will be approaching 0. So that's how our equations will look different. So here is the equation for the secant line, f of a plus h, so that's the y-coordinate for q, minus f of a is the y-coordinate for p. All over, well, what happened to the a's? Well, if I do a plus h and I subtract a from it, I'm left with just h. So that's where this denominator has come from. And then when we come to looking for the slope of the tangent line, we're finding the limiting value as h approaches 0. We'll call this Formula 2. Well, let's try some examples. We want to determine the equation of a tangent line using Formula 1 for question 3. So, Formula 1, as we saw, my slope will be as x approaches -2, so that's my a value. Here we have a is equal to -2 of the equation for my secant line slope. F of x minus f of -2 over x minus -2, which is the same as x plus 2. Well, we have an explicit equation for that function, so we can substitute in. So we'll find the limit as x approaches -2 of this function, where we've replaced f of x with what it's equal to, x squared minus 3, and that's what we have here. And then we'll subtract f of -2, I replace the x with a -2, and I have -2 squared minus 3 in my numerator. Well, can I plug in a -2? Well, as we found previously, whenever we were looking at slopes, if my x is approaching a -2, my denominator is going to 0. My y values will also be approaching the same value, so they'll be going to 0 also. So we're going to look to see if we can find a common factor here. So as we simplify the numerator, this -3 that we have over here, then we're subtracting this -3. So these two -3's are canceling out completely, and what I'm left with is just this x squared minus -2 squared, which is a positive 4, which gives me the x squared minus 4. Well, from here it looks pretty nice, because you will recognize that difference of squares in the numerator that we can factor. Once we factor that difference of squares, then we can see the common factor, and the common factor of x plus 2 will cancel out. I should use a different marker. There we go. This and that cancel. Now we can plug -2 in, and we discover our slope is -4 at the point on the function where our x value would be 2. So again, this a is actually an x coordinate, and we're finding the slope of our function when x is -2, our slope is -4. Well, then we find the equation. We have y2 minus y1. So where did this 1 come from? Well, let me grab a different color here. What is f of -2 equal to? Well, that's this part of our formula here. If we could get rid of all that scribbling over top, -2 squared is 4, minus 3, oh, that gives me 1. So when a is equal to -2, my f of -2 is equal to 1. So that's where this value came from. My slope is -4, and then I have the x minus the -2. We will rearrange this to put it into standard form. So there we go. We found the slope of the tangent line, and we found an equation for the tangent line for an x-coordinate of -2. I would like you to use the same formula to determine the equation of the tangent line for this function. So at this point, pause the video, please, and finish this question. Restart the video once you've completed the equation for the tangent line. Well, here's how I've started. This time I wasn't told that a equals 2, but I was given this xy ordered pair, which is kind of nice. It gives me both the x-coordinate and the y-coordinate for this point that we're looking at. So as x approaches 2, f of x minus f of 2 all over x minus 2. I substitute those values into the function. So f of x, there's my f of x function. I already know that f of 2 is equal to 1 from this y-coordinate that I was given there. So I don't even have to do a lot of work to evaluate that. My numerator and denominator are both going to 0, so I need to do some simplifying to find a common factor. So because I had a negative in front of my squared term, I chose to factor that out because I find it easier to factor quadratics when my leading coefficient is a positive. Then we could do guess and check or decomposition. Either way, we're going to come up with these factors of 2x plus 1 and x minus 2. And again, we're expecting a common factor of x minus 2. So if I already know that one of my factors is x minus 2, then guess and check is going to be a fast way to do this question. Because I need to say, well, what do I multiply to this x here? Let me choose a color. What do I multiply to x in order to get 2x squared? Oh, I have to multiply 2x. Here, I had a -2. Here I had a -2. What do I multiply to -2? A +1. So factoring is much easier when I already know what one of the factors is. So that can save some time. That common factor cancels out, and we get this work. We get a slope of -5. We plug it into our slope-intercept form for the equation of the line and rearrange into general form. Next example. This time we're going to use Formula 2. Formula 2 is that one where h was approaching 0. So here's what my equation will look like. Again, I'm given an xy ordered pair for the coordinates where I'm looking for the equation of the tangent line. This formula, because it's a little bit newer, tends to be the one that students don't try first. So let me encourage you to push yourself to get familiar with this formula. This will be a very significant formula as we go forward in this course. So even though Formula 1 looks more familiar, try to get more familiar or equally familiar with this formula. Well, what happens when I do the substitutions this time? Now my x gets replaced with the 6 plus h, where I had f of 6 plus h. And then I know that f of 6 is equal to 2, again, from this ordered pair that I was given at the start of the question. Underneath the radical sign, I can collect those constant terms together. Oh, but wait, before I get to this, there's another step. Let's look at this. I need to multiply by the conjugate. So here I haven't written it already, but this -2 and that +6 will simplify together to give me the 4. So this whole radical is actually the same as the square root of 4 plus h. So that's where this 4 plus h is coming from as I'm multiplying by the conjugate. Now when I do that, in the numerator, my radicals cancel out, so I get a 4 plus h. Foiling, the outside and inside terms cancel, and the -2 times +2 gives me a -4. This is what we're always expecting to see, where we have this constant cancels out, and then we just have an h left in the numerator, and we can see that common factor between the numerator and denominator. So as h approaches 0, we're always expecting to find a common factor of h. The h's will cancel out. So let me just show that. So this h cancels with that h. This h is going to 0. So what happens? My numerator is 1 over the square root of 4 is 2. So this whole thing becomes a 2 plus a 2. That's where the 4 in the denominator comes from. Once we have the slope, we can figure out the equation for the line using the point that we were given. Let me continue. Pause if you need to, but I will continue. So that was a radical function. Here we're going to look at a rational function using the same formula. So again, I'm going to look at f of 7 plus h. So looking at this x-coordinate is my 7 minus f of 7 all over h, and we're doing the limit as h approaches 0. We'll substitute, replacing all the x's first with the 7 plus h, and then I have that 7 halves as this f of 7 value. Well, again, to move forward, I need to do a little bit of simplifying here. So this 7 and this minus 5 will simplify to give me a positive 2. So here in this denominator, I actually have, I'll just write it to the side here, I have a 2 plus h, or an h plus 2. Would have been good if I'd written that as a separate line, but I think I know what's coming here, which is, yeah, to multiply by that common denominator. So here I have the denominator of 2, so I want to make sure I multiply by 2. And here in my denominator I have a 2 plus h, so I want to multiply by a 2 plus h as well. When I expand this out, here I did make the step a little bit smaller, which is a good thing. So I have the 7 plus h is here, multiplied to the 2 times 2 plus h, and I can see these 2 plus h's will cancel out. And then on this side, I can see that these 2's will cancel out. And then I don't have any fractions in that numerator anymore. So that makes it a little bit nicer, so that as I do some distribution, this 2 gets distributed into the brackets here to give me the 14 plus 2h. And this 7, and I'm going to take that negative sign with it. That negative 7 gets distributed in to give me a negative 14 minus a 7h. So that's where we get those terms. Again, as h was approaching 0, numerator and denominator both go to 0, so we're expecting to see that there will be a common factor of h, and we are getting these constant terms to cancel out because of that subtraction. Then I have a 2h minus a 7h, which will give me a negative 5h. Now we can see that common factor. So the h's will cancel out. This h is going to go to 0 because h is approaching 0. And what does that leave us with? Looks like a negative 5 over 4. And again, at this point, this h is the one that's going to 0. Notice again that we had to keep the limit notation all the way through until we were able to replace the h with 0. Once we have the slope, again, I can use that point slope form. My y-coordinate was 7 halves, x-coordinate was 7, and my slope, negative 5/4. Rearrange, and there is the equation for our tangent line for this function. Pause if you need, because I'm going fairly quick. But to keep this video not too long, we'll jump to the next page. And here we have check your understanding questions. So pause the video, complete these check your understanding questions, and then restart to compare your answers with mine. Notice that for both of these questions, I'm asking you to use formula 2. Again, pushing that unfamiliar formula to make it more familiar to you. Here we go. There's my answer for this question. This time we were just given the a value, so I needed to calculate what f of negative 3 was equal to. So I needed to do all this work here that I didn't have before. Negative 1 minus a negative 3 gave me a 4. Square root of 4 is 2. That's why I have this 2 over here as I look at multiplying by the conjugate. Similarly here, as I simplify this radical, I'll have a 1 minus a negative 3, which gives me 4 minus h. So I have the 4 minus h as my radicand. As we have come to expect, the constant terms cancel out. Then I have the common factor of h that will cancel out. My leftover h that doesn't cancel will go to 0 because I'm doing the limit as h approaches 0. And we get a slope of negative 1/4 to plug into our equation and figure out the equation for the tangent line. Question number 8. Here's my process again. This time we were given a y-coordinate for our point where x is 4, so that made it a little bit easier to get this 2/3 at this point. We have fractions again. This time I showed a little bit more work, which is kind of nice, so that as we look at this next line, where I have this 4 plus the 2, that gives me the 6. So then it's easier to see that I have this 6 plus h common factor, and the 3, I should say, as part of the common denominator. Multiplying those in, we'll get the next line. And you can see what's canceled out with those yellow strokes. And I can distribute this 3 into my brackets to give me the 12 plus 3h. I can distribute this 2 into those brackets, which is where I'll get this 12 and the 2h, but let's take this negative sign with it. So we'll multiply everything by negative 2, which is where we'll get the negative 12 minus the 2h. As we are expecting, the 12s cancel out. 3h minus 2h gives me h. Those two h's cancel. This leftover h goes to 0, and we get our slope of 1/18. Plug it into the slope-intercept form for the equation of the line with the ordered pair we were given when x was 4 and y was 2/3. And here is our equation for the tangent line in standard form, or general form, I should say. And that finishes this lesson. Hopefully that's a nice relief after the previous 2 lessons. Time to do some practice in your textbook.